In this orthokeratology case, we have a patient whose corneal toricity and refractive cylinder are at opposite axes. We can see that there is about 3/4 of a diopter with the rule on the cornea, and then 3/4 of a diopter against the rule in the refraction. So this suggests that this patient probably has around a diopter and a half, some sort of internal astigmatism. And as we mold this cornea, then more and more of that internal astigmatism starts to come out. So basically we end up with a post-treatment refraction that's got more cylinder power in it than what the patient started with, and the patient does have reduced vision. So what we're going to do is try to make some lens changes that will um, help us to not sphericalize this cornea. Basically, we want to leave as much with the rule toricity on the cornea as possible because we want that to cancel out what is already present inside the eye. In fact, if we could, we might even want to create more toricity on the cornea to counteract the full diopter and a half or so that's behind the cornea. So that's difficult, but at least we can hopefully try to maintain what the cornea currently has. So basically what we want is less correction in the vertical meridian here. And this current lens fits pretty well, centers fairly well on the eye, and so we don't need to make too many adjustments with regard to how the lens positions on the eye. We just want to affect how the lens corrects or alters the shape of the cornea. So there are a couple strategies. One is to create a toric base curve. Another one might be to go with an oval optic or treatment zone. But another way to do it is to adjust how the lens seals off in the back image of the reverse curve. We know that beyond a diopter, or maybe a diopter and a half, in orthokeratology, we need both a pull in the periphery as well as a push in the center. So we can reduce pull in certain areas, and the idea is we can reduce how much molding we're going to get. And in this case, again, the reduced molding we want is here in the vertical meridian. We're in freeform mode, and the lens is already prism ballasted, and so I think we can leave those as they are. We can start here in the 6 o'clock meridian, and we'll do this in 50% mode. We'll right-click to see where we're starting from, and so we've got sag, that's 743 and 1986. So since this lens aligns or fits pretty well, we'll keep the pink control point at 1986. What we want to do is decrease seal here. So 743, we will decrease sag here, and I'm going to pick a number of 20 microns, and so our new target is going to be 723 here. And we'll speed this up a little bit by going into 8x. And we're almost there. Okay, a little too much, so we'll come back down one. Okay, so now we're at 723. So you notice when we adjusted the IC or blue control point, it also changed the position of the vertical position of the pink or the edge control point, and we want to bring that back. So right now at 1957, we started in 1986, so we want to bring that back down to 1986. And we're a little bit past. And we're right at 1986. Perfect. So now we are 20 microns flatter or 20 microns less sag here at the back edge of the reverse curve with no sagittal change here at the edge. So it looks like the lens, there's more clearance at the lens right here, but I think this is just the nature of how the display works. I recommend just going by the sagittal depth of the lens and making sure that number lines up. So since we're in freeform, this change only affects bottom half or so of the lens. So we can either click up or we can just simply go over to this side and see this is the superior part of the lens now. We're at 752 and 2005, so our new endpoint will be 732 while maintaining 2005 here. We're at 732, and now we just need to readjust out here back to 2005. We can go one more. And now the superior meridian is adjusted as well. So now as we kind of walk around the lens, we can see that there's better seal off here in the horizontal. And then as we head toward vertical, it becomes less and less. And the idea is that we want less molding, less treatment in this meridian. So I think this patient's refraction currently is plano -2 approximately, and I don't think it'd be a bad idea to go back to 100% mode and maybe flatten this base curve another quarter diopter, because if we can get the patient down to plano -75 or plano -50, then maybe plus a quarter -50 or plus a quarter -75 might even be a little bit better. And so back in 100% mode, because we'll do this all the way around, we'll just click up here and get the lens power up to about a plus 150, which will be equivalent to flattening the base curve by a quarter diopter. I think I like that previous one a little better. So anytime you change the base curve, especially if you're in freeform mode, I recommend clicking through the different meridians in 25% mode, because you can probably get a little bit closer to target in individual meridians. Even though we did that change in 100% mode initially, it's not always uniform all the way around. We didn't make a huge change in only a quarter diopter. If you make changes on the order of half, 3/4 of a diopter, you will find that you end up actually sometimes with a very unusually toric base curve, and we do want to go and fine-tune each of those meridians. So I won't go through right now and do all of them, but we did a few of them just so there's a demo and an idea of how to do that. At this point, I think the lens is ready to order. And I mentioned earlier, it's already prism ballasted, which I strongly recommend, especially since we have this asymmetric treatment on a not very toric cornea. Having the prism ballast will at least help us to initially see how the lens is orienting. So ask the lens to to dot the lens so that you can see how the lens orients, at least behind a slit lamp.